Hi kids, we are going to introduce and just briefly go over equivalent expressions in this video, okay? If the video goes fairly quick, you can always rewatch it during tutorial or at home, okay? Because this is just kind of an introduction to get you used to the vocabulary we will use and the processes we will use, okay? When we actually go to the lesson and teach it full out, all right? Now, the first thing that's important to remember is this. Equivalent expressions are expressions that are the same, okay? In other words, they're going to give us the same value. They're written differently, but they give us the same value, okay? So, equivalent expressions are expressions that are the same even though they may look a little different, okay? So, they're going to be worth the same value, but they look differently, okay? Because sometimes you like to rearrange things in algebra to help evaluate and solve. Now, if you plug in the same variable value into the equivalent expressions, they will each give you the same value when you simplify them. Okay, so equivalent expressions are expressions, okay, that will give you the same value if you take the variable and plug in a value to that, okay? Now we're going to go over that a little bit right now to help kind of like clear that up, okay? So here's an example of a set of equivalent expressions. Now remember, values of expressions stay equal to each other for any x value when you're talking about equivalent expressions, okay? So let's just take a look at this expression here. This is 2x minus 9. The variable is x, okay? Now, it is equivalent to this expression. X plus 3 times x minus 3, okay? Now, in this case, they've given us a value of x so that we can actually compare and say, is this equivalent to this? Well, all we have to do now is substitute the x for the value of x that we've been given. So we will rewrite this as 4 to the second minus 9. And then we will write this as 4 plus 3 times 4 minus 3. Remember, this is multiplication in there. Okay? So now we would do 4 to the second, which is 16, because 4 to the second is 4 times 4. So we have 16 minus 9. Over here, we would add the 4 plus the 3, and we would get 7. Then we'd add the 4, or we'd subtract 4 minus 3, and we'd get 1. So now we would simply do the multiplication, and we would have 7 times 1 is 7. And then, of course, 16 minus 9 is 7. And so what we've created is we can see that this expression, okay, over here is equivalent to this expression right here. It's just that they have a different way of saying it, okay? Now, in your book, they're going to talk about different ways of creating the expressions. And they will say that you can use the properties of operations to write equivalent expressions. So those properties of multiplication and addition can be used to help us create equivalent expressions. Properties such as the distributive property, where you rearrange things, you know, and the associative property, where you regroup things differently. Okay, so these are two properties that you could use to create equivalent expressions. Let's go over an example for you, okay? Now, how can you use the properties of operations to write an equivalent expression for this expression? So here's the expression. And what we want to do is we want to create an equivalent expression that would give us the same value of this if we plugged in a value for x, whatever it might be, okay? And we can do that by using the properties, okay? And we're going to start by using the distributive property to expand the expression. So we're going to expand it using the distributive property. And then we're going to use the associative property of multiplication to regroup the first term and then multiply 2 times 5. So, let's take a look at how this would really shake out. Okay, so we're going to take our expression, which is 2 times 5x plus 7, and here's the equivalent expression that we would create following these steps. Okay, it would be 2 times 5x plus 2 times 7. Well, we came up with this expression right here using the distributive property. In other words, what we did was we took the 5x and distributed it to the 2, and then we took the 7 and distributed it to the 2 right there. Okay? Now what we're going to do is we're going to use the associative property, and we're going to group things together. Okay? So now what we're going to do is we're going to take the 2 times 5, and instead of doing 5 times x, we're going to do 2 times 5 and have the x right there. And then we're going to take 2 times 7 and get 14. So it's almost like we're making it simpler. And then we're going to take it even farther, and what we're going to do is we're going to do 2 times 5 will give us 10, and we'll bring down the x, and then the 14 stands alone. So there we have proof that it is an equivalent expression. And then we could plug in a value for x and actually test it and see if it works. So in other words, we could actually say, let's give x a value of 3. And so if we did that, we would say, okay, this is going to be 5 times 3 plus 7, okay, times 2. So 5 times 3 is 15, plus 7 is 22, and then multiply that by 2, and you get 44, okay? So then if we do that, and then we do, okay, well, let's do 10 times 3, okay, plus 14, and we do 10 times 3 is 30, and then 30 plus 14 equals 44, okay? So we did create an equivalent expression by using the distributive property and the associative property, okay? All right, hopefully that helps you out. If not, you can watch the other videos posted, or you can see the teacher during tutorial.